Okay, good day everyone. So this video presents the discussion on the properties of triangles. So number one, we have altitude. So an altitude is a line segment drawn from a vertex perpendicular to the opposite side. There are three altitudes of a given triangle. So we have here, huh? So an altitude is a line segment drawn from a vertex then perpendicular to the opposite side. So since we have three sides, we can draw also three altitudes of a triangle. And the three altitudes intersect at a common point, and we call that common point as the orthocenter. Okay? So take note of the terms now because in the succeeding examples, possible, no? Or when you take the exam, no? Quiz, or you solve problem in your practice, then possible you encounter the term. So you need to know. You should know what is the meaning of the term. Okay? So altitude is the intersection, altitudes, then we have orthocenter. Na? So orthocenter is the intersection of the three altitudes of a triangle. Number two, we have median. So median is a line segment drawn from a vertex to the midpoint of the opposite side. Okay? So line segment drawn from a vertex to the midpoint of the opposite side. So if we have here a triangle, so we can draw a line segment from the vertex to the midpoint of the opposite side. So if I will call this side as side A, then this measures A over 2, A over 2. We can draw another median. So if this is side B, then half B over 2, B over 2. Third median drawn. So if this side C, so we have here C over 2, C over 2. Okay. So the three medians intersect at a common point, and the common point is what we call the centroid of the triangle. Then we have here angle bisector. So angle bisector is a line segment drawn from a vertex to the opposite side and bisecting the vertex angle. So angle bisector meaning when you draw that line segment, it will bisect an interior angle. So if we have here, for example, so this is an angle bisector of angle B, angle A. No? So this is, or this measures A over 2, A over 2. So I can draw an angle bisector of angle B. So this is being bisected, so this measures B over 2, B over 2. I can bisect also angle C. So I have here the measure of the angle C over 2, C over 2. So the three angle bisectors also intersect at a common point, and we call that the incenter. Why? Because we can draw a circle inscribed in a triangle, and the center of that circle is the intersection of the angle bisectors. So we call it the incenter. Okay. So what do we need to know for the properties of the angle bisectors? So if this angle bisector, if I will consider the angle bisector of angle B, and then it intersect the opposite side somewhere here. So the opposite side AC is now being divided into two parts. I will call it X and Y. And if this is side A and this is side C, then we have the relationship of the sides, so that is A over X is equal to C over Y. Then for the inscribed circle, we can have the radius R. So the radius R is the perpendicular distance from the incenter to the, or to any of the sides. So what is the relation or the formula to be used? So the area of the triangle A is equal to R times S, where R is the radius of the inscribed circle and S is called the semi-perimeter. Now, semi-perimeter of the Heron's formula. Okay, now, can have a formula for the shortcut for the length of the angle bisector. Na? So, if I will call this angle bisector with length L, na? Then the length L can be easily solved by using this formula. So, L squared is equal to AC minus XY. So, AC, then we have XY. Then extract the square root on the right side to get the length of the angle bisector. Okay? Next, we have perpendicular bisector. So, perpendicular bisector is the line segment drawn perpendicular to a side and passing through the midpoint. So, kaya nga, we call it perpendicular bisector. It bisects a side, and also it is drawn perpendicular to that side bisected. So, we have that here. So, angle bisector of that side, perpendicular bisector of that side. Then we have another perpendicular bisector, another perpendicular bisector. Okay. So, the three perpendicular bisectors intersect at a common point. And we call this common point as the circumcenter. Why? Because we can draw a circle which touches all the three vertices. And we call it as the circumscribed circle of the triangle. So the radius of the circumscribed circle is the distance from the center, the circumcenter, to any of the vertices. So that is the big letter R. So what are the relations? If A, B, and C are the three sides, if A, B, and C are the three sides, then the area of the triangle is equal to A equal to ABC over 4R. So where ABC are the three sides, R is the radius of the circumscribed circle of the triangle. Okay, so we have X circle or Exscribed circle. So an X circle or Exscribed circle of the triangle is a circle lying outside the triangle, tangent to one of its sides, and tangent to the extensions or the prolongations of the other two. So, let's say we have this triangle. So, I can extend the two sides here. And then I can draw a circle outside the triangle and touches or tangent to the two prolongations and the third side not extended. So we call that circle as the Exscribed circle. So the radius is R. And then what is the relation? The area of the Exscribed circle or the area of the triangle, So the area of the triangle is equal to R times S minus A, where R is the radius of the Exscribed circle and A is the length of the side of the triangle to which the circle is tangent to. Okay? Next, problem. We have now the problems. So problem 1. In triangle ABC, C equal to 40, angle C is 70, and angle DA is 45. Determine the length of the median from vertex A to side A. Okay? So, as what I have said, trigo problems, geometry problems, the same lang to sila. So, they are just the same. We need to read the problem, understand, and then draw the correct figure. Then analyze from the triangles or from the figure, what formula you will apply in order to solve for the requirement. Okay. So, I have here triangle ABC. So, side C, 40, so opposite of angle C. So, we have here small letter C, 40. Angle C and angle A are given. So, we have angle A equal to 45. Then, angle C equal to 70. Okay. Determine the length of the median from vertex A to to opposite side A. So, if we recall median, line segment drawn from a vertex to the midpoint of the opposite side. So, if I will draw a median, so we have here. So, meaning, this point bisect, no? This point bisect A. So, this is A over 2. This is also A over 2. So, what is the length of the median M? Okay. So, what is our approach in solving the problem? So, I can solve for side A by using sine law, no? So, I can solve for side A by using sine law because we have this side and opposite angle, unknown side, and then the opposite angle is given. Okay. So, after I have side A, I can have half of that, no? This angle B, we can solve this because we are given two angles, so we can solve for the third, for this triangle ABC. So I have that here, no? So by sine law, I have A over sine 45 equal to 40 over sine 70. And I can solve for A, that is 30. So meaning this is A over 2, 15. Same with here, A over 2 equal to 15. Okay. I can solve for angle B, so that is 70 plus 45 plus B equal to 180. So angle B here is 65. So, have you noticed that I can now solve for M by using cosine law? Because I have this side 15, I have this side 40, and then this angle 65. So, by cosine law, I can write M squared is equal to 15 squared plus 40 squared minus 2 times 15 times 40 cosine of 65. And M will come out 36.6 meters. Okay, so that is problem number 1. Problem 2, we have here. Triangle ABC has sides AB equal to 21, BC equal to 13, then CA equal to 20. Find the length of the bisector of angle A to side BC. So we have discussed this, na? Angle bisector, length of the angle bisector. Okay, so we will draw the triangle. So triangle ABC. AD equal to 21, BC is 13, and then CA is 20. So find the length of the angle bisector of angle A to the opposite side BC. So we have that here. Then I will call the length L. So we have the relation of this, no? So if this segment of the opposite side BC is X, no? And then this remaining segment is 13 minus X. And then I can apply the relation, no? So I have X over 21 is equal to 13 minus X over 20. And X is 6.66. Then, I can solve for 13 minus X. So, that is 6.34. So, if you recall, we have the formula for L. And L squared is equal to the product of the two sides, 21 times 20, minus the product of the two segments. So, 6 minus 6.66 times 6.34. And L is 19.43. So that is problem number 2. Okay, we are here. Problem 3. Given triangle ABC, point A is alongside AC and point B is alongside BC. Ayan lang muna. So we will plot it first so that we can read each sentence and then start plotting. So that you will not be mixed up with the next sentences and given situation. Okay. So triangle ABC with point E alongside AC. So alongside AC there is a point A somewhere here. And then alongside BC, there is a point alongside BC, a point D. I'll place it somewhere here. Huh? So line BE, so we will connect BE by a line. And line AD, we will connect AD by a line. Huh? Are angle bisectors of angle B and A respectively. So meaning, line BE is an angle bisector of B. And line AD is an angle bisector of angle A. Then, if the angle BEC, where is BEC? This angle is equal to 75, and angle ADC is equal to 84. Find angle ACB. So, ACB. Okay? So, we will place the angles now. So, BEC is 75, and then ADC is 84. Okay, now. Since this is bisectors of angle B, no? Bisector of angle B, so I can divide angle B into angle A first. No? Okay, so this AD bisect angle A, so theta, theta. Here we have alpha, alpha. Okay. So the question is the interior angle at C, no? Angle ACB. So how will we solve it? Okay. So I can consider triangle ABE. Can consider triangle ABE. So, by the way, this angle is 105 na, because we have 75, so 180, so 105. How about this angle? This is 96 na. Okay, so I can consider triangle ABE. So, triangle ABE, so we have here 2 theta, alpha, and 75, 105 na. So, if I will sum up the three angles, so 2 theta plus alpha plus 105 equal to 180. So, I will come up with 2 theta plus alpha equal to 75. So, I will call it equation 1. I can consider the next triangle, triangle ABD. So, ABD. So, this triangle, huh? So, I can sum up also the three angles that is equal to 180. So, theta plus 2 alpha plus 96 equal to 180 degrees. And I have theta plus 2 alpha equal to 84, second equation. So, I will solve for alpha and theta from the two equations. No? So, equation 1 times 2. So, this becomes 4 theta plus 2 alpha equal to 150. Then, pair to equation 2, theta plus 2 alpha equal to 84. So, when we subtract, we can eliminate alpha. So, I can solve for theta equal to 66. Or theta equal to 22 degrees. So, 3 theta is 66. So, theta is 22. Okay. So, after I have angle theta equal to 22, I can now solve the requirement by using half or by using this triangle, no? ACD. Where we have angle theta 22, angle 84, the only unknown is angle C. So I can consider triangle ACD. So theta plus C plus 84 equal to 180. So C is equal to 74 degrees. Okay, so that is problem number 2. No? Next problem, number 4. Number 3, I mean. We will now go to number 4. In triangle ABC, C is 30, A is 36, and B is equal to 18. Find the radius of the circle tangent to the side C and Exscribed outside the triangle. Okay, so this is an Exscribed circle, no? I think this is not so difficult, no? We will draw the triangle, so ABC. So, A is 36. side B is 18, side C is 30, and we will draw an ascribed circle which is tangent to side C. So, extend the other two sides and then draw an ascribed circle tangent to side C. Okay? So, find the radius of the ascribed circle. We have a formula for this. But first, we will solve for the area using herons. So, S is the semi-perimeter. The sum of the three sides divided by 2. So, S is equal to 42. Then we can solve for the area of the triangle using Heron's formula. So, by substitution, that is 269.4. Then, area of the triangle is equal to R times S minus A. So, relation between area of the triangle and the radius of the ascribed circle. So, the circle is tangent to side C. So, we have here S minus C. So, substituting computed values, we can solve for R, that is 22.45. So, we have problem number 4, na? Okay. Problem number 5. I hope am I too fast in my discussion? Anyway, you can view the video as many times as you want, na? You can view the video as many times as you want. So, then, I am making the video segment by segment, no? Topic by topic, so that you can just review the topics that you need, no? And not viewing all the topics of the subject, no? Per view. So you can just, I want this topic, so you can view that topic, no? Okay, problem number 5. So, the sides of a triangle are A, 6, B, 8, and then C, 10. Find the area of the inscribed circle. Okay, so inscribed circle, the circle drawn inside and tangent to all the sides. So, I have here the triangle. So, side A, side B, side C. Then we have the inscribed circle. So, what is the radius of the inscribed circle? Then, compute for the area. So, I can solve for the area of the triangle by using herons, no? So, area is A plus B plus C, or the semi-perimeter. That is 12. Then we have area computation, herons formula. I think you are familiar with that already. Then, for the inscribed circle and the area of the triangle, that is related by this equation. Area equal to R times S. We have computed the area and the semi-perimeter. So, R is equal to 2. So, the requirement is the area of the inscribed circle. So, pi R squared, where R is equal to 2. So, area is equal to 4 pi. So, that is very easy question. That is just knowing the relation, the formulas to be used. Okay. We have here number 6. In triangle ABC, AB equal to 30, BC equal to 36, and AC equal to 48. The perpendicular bisectors of the sides intersect at P. So, perpendicular bisectors. How far is P from side BC? Okay? So, again, we are given triangle ABC. So, we have the sides. AB is 30, BC is 36, and then AC 48. By the way, you may not draw the triangle as scale as possible, no? Anyway, we are just approximating as long as we can draw the figure. Pero, if you can draw, no? The suggestion is, if you can draw the figure as scale as possible as the given dimensions, it is advisable to do it. But if not, anyway, we can just check the answer, no? Okay. So, we can draw perpendicular bisectors on the three sides, no? Okay. So, I can bisect side AB. So, 15, 15, and then we can draw perpendicular bisector. Next side, so 18, 18, then bisect this side, so 24, 24, and then bisect. So we know that the three perpendicular bisectors intersect at a common point, and we call it point P, no? So that is point P. And this is the circumcenter. So we can draw a circle circumscribing the triangle. So the question is, how far is P from side BC? So this distance is the requirement. So I will call that D. Okay, so have you noticed that from vertex B to point P, this is the radius of the circumscribed circle R. And if this is 36, so this is 18, this is 18. So if you can solve for R, then this is half 18, then we can solve for the requirement by Pythagorean theorem. So notice that we have already shown the steps, no, or the flow of our solution. So again, solve for R, the radius of the circumscribed circle, and this is 18, and we can solve for the requirement by Pythagorean theorem. So we can solve for the semi-perimeter of the triangle 57. Okay, I will move to the next slide now. So we will note the sides of the triangles 30, 36, and 48. S is 57. So anyway, what we are doing here is the Heron's formula to compute for the area. So 57, then subtract, so 539.32. So the area of the triangle is equal to ABC over 4R. We have the three sides. So R is 24.03. So meaning, I will go back now. So if this is 24.03 and this is 18, so the distance D is 24.03 square minus 18 square. And extract the square root. Okay, is that noted? So we have that here. So 24. So correction, this is 24. I think the answer is correct. This is just misprinted. So instead of 24, that is 21. I will check. 21.03 square minus 18 square. Then extract the square root. So the answer is 10.87. So 24.03 square minus 18 square. Extract the square root. So the answer is 15.92. So the answer is correct, but just change this into 24.03. Just correct this by 4. Replace this by 24.03. Okay, so that is about that problem number 6. Okay. I think this is the last problem. So problem 7 for this topic. A circle is circumscribing triangle ABC. A circle is circumscribing triangle ABC with sides A equal to 16 and B equal to 20. And an altitude of 18 to side C. Side C is the unknown side of the triangle. So we are given side A and side B. So unknown yung side C. And the altitude to side C is given equal to 8. Find the radius of the circumscribed circle. Okay, so we will draw. So I have triangle ABC. Side A is here, 16. That is circumscribed circle. Side A is equal to 16. Side B is 20. This is the unknown side C. Then we can draw an altitude to the unknown side C, and this altitude is equal to 8. What is the radius of the circle? Itong circle. So notice that if we use the side C and the altitude H, I can solve for the area of the triangle, and that is equal to 1/2 H times C. So area of the triangle is equal to 1/2 this side C as the base times the altitude h equal to 8. I call that equation 1. Now, also, if I have C here, I can express the area of the triangle in terms of the three sides and the radius of the circumscribed circle. Huh? Area of the triangle is equal to ABC over 4R. I will call that equation 2. So I can equate the two. So 1 half AC equal to ABC over 4R. Now notice that the unknown side C cancels out, and I have already, or H is given, that is 8. The two sides AB are also given, and the only unknown for this equation is the radius of the circumscribed circle R. So I can solve for R, and that is equal to 20 cm. Okay, so again, this video presents the discussion on the properties of triangles. So just view again so that you can study the topics and the strategy, develop the strategy in solving similar problems. Okay, thank you.